Hi everyone. We're going to find limits of rational functions involving absolute value functions. I'm going to do a simple one, and then I'm going to do a special request that someone asked me to do. So we have a function x over the absolute value of x, and we want to know what happens as x approaches 0 from the negative side. From the left. This just means here that x is less than 0. So remember that. Now, when you do absolute value, you need to know that we can piecewise the absolute value function as such that absolute value of x equals x if x is greater than 0 or positive, and absolute value of x is x if negative x if x is negative. So we want x to be negative here because we're approaching 0 from the left. So that's all numbers smaller than 0, which are our negative numbers. So what I'm going to do, since I'm talking about this one, I'm going to look here. And I'm going to substitute and write my limit as x approaches 0 from the left of x over negative x. Now that's going to equal your limit as x approaches 0 from the left of negative 1. And I'll do this. And you know that when you take the limit of a constant, it equals a constant. So the limit as x approaches 0 from the left is negative 1. So that's your left side limit. Let's try the right side limit. So the right side limit would be the limit as x approaches 0 from the right, which basically all that means is that x is greater than 0, or x is positive. So this is of x over the absolute value of x. So what we want to take is this one right here, because that's where x is positive. And we're going to substitute like we did before and write down your limit and substitute. We're going to get x over x. That equals 1. Since both the left side and the right side don't equal, the two-side limit does not exist. And that would be your answer if you had to do both sides. Okay, the next problem I'm going to do is a little more complicated, but it's not that bad. So we have the limit as x approaches 9 from the left of x minus 9 over the absolute value of x minus 9. Now, I'm going to go ahead and write, remember, the absolute value of x can be broken down piecewise as x when x is positive and negative x when x is negative. So what I can do here, I can use x minus 9. Everywhere there's an x, here I'm going to substitute x minus 9. So for this x here, I'm going to write x minus 9 when x minus 9 is positive, and negative x minus 9 when x minus 9 is negative. Okay, all I did was substitute the x for x minus 9. And what I'm going to do on this side right here, let's see, this area right in here is just simplify. So we're going to have the absolute value of x minus 9 equals x minus 9 when x is greater than 9, and negative x minus 9 when x is smaller than 9. Okay, and now let's try to take our limits. So we want to take it from the left side first. What that means is that x is less than 9, so all numbers smaller than 9, and I'm going to substitute for x is smaller than 9, we're going to use, let me put the parentheses here, we're going to use this right here. I'm going to substitute. So I'm going to rewrite the limit as the limit as x approaches 9 from the left of x minus 9 over negative x minus 9. Now, these two cancel here, and you're left with negative 1. So you have the limit of x as it approaches 9 from the left of negative 1, and the limit of a constant is just the constant, so that's negative 1. All right, and now let's take it from the right side. That's going to be the limit as x approaches 9 from the right. All that means is x is bigger than 9, and here we have it right here. So I'm going to substitute, and that's going to equal x minus 9, and I'm just going to substitute this for x minus 9, and that equals positive 1. So the limit as x approaches 9 from the right equals 1. Since the limits don't match, the two-sided limit does not exist. I'm going to do two quick graphs of this to show you. You can see it better graphically. So I'm going to graph the first one that we did, which was the simpler one, which is y equals x over the absolute value of x. Or let's just use f of x here. F of x. All right? And so what we're going to do is, we know the limit is 1, so I'm going to write this as 1 and negative 1. I'm going to write open circle here because it can't equal 0. And that goes that way. And this one goes this way. This is 0. So as we approach 1 from the right, as we approach 0 from the right, we get 1. As we approach 0 from the left, our y value is negative 1. So that, therefore, the limit doesn't exist. And the other one that we did, so the other one was f of x equals x minus 9 over x minus 9. Basically, the absolute value of x minus 9, that's just a shift to the right by 9. Right here. And I'm going to go up to here about 1. I'll just do 1 here. So that's 1, negative 1. So from the right, we have an open circle, open interval, goes this way. And from the left, it goes this way. So as we approach 9, right here from the right, we come up with 1. And as we approach from the left, it just stays at negative 1 from the left, and it stays at right. From the right, it stays at 1. So that's why the limit doesn't exist. There's a jump in discontinuity.